A register stores the following binary number: 11001101. The binary value in the register represents an unsigned binary integer. Convert the unsigned binary integer into denary. The first thing to notice about this question is that they mention that the number here is unsigned. This means that it is a positive number. So whenever we say a number is unsigned, it means it doesn't have a plus or a minus. If we write a denary number like this does not have a sign before it, meaning it is a positive number. If we add a sign before it, let's add the negative sign, this would now mean -30. So to recap, unsigned means that this number is positive. When we're converting this into denary, we're going to follow the same method that we've done in the past. This method is to first write out our number, and underneath the number, starting from the least significant bits, we're going to write down the denary equivalents for each bit. Starting at 1, multiply that by 2, multiply that by 2, and continuously multiply this by 2 until we're finished. Now going from left to right, we're going to circle the numbers that have a 1 and cancel out the numbers that have a 0. First number, we circle the 128, circle 64, cancel 32, cancel 16, circle 8, circle 4, cancel 2, and circle 1. We then add these numbers together. Keep in mind we only want to add up these circled numbers, and the result that we get is going to be 205. Let's write in that answer over here, and that is part A complete. Part B says, the binary value in the register represents a 2's complement binary integer. Convert the 2's complement binary integer into denary. Here, they tell us that the binary integer is in 2's complement. This means that we've split up our range of 8 bits into 2 different parts. We now have a negative part, and we have a positive part. The way we differentiate between these two is whenever the first bit is a 1, that is going to be a negative number. Whenever the first bit is a 0, it's going to be a positive number. In this case, we have a negative number given by the first bit being a 1. What this means in terms of our conversion is that we can't follow this method we used in part A, because that would give us a positive number, since we're only using positive numbers as our bit representations. There are 2 ways to go about this problem. The first way is to convert our binary number into its positive representation. Then we could use this method to work out the positive denary number and put a minus sign before it. That method takes a bit long, so we're going to use a very similar method to part A. We're going to write out our binary number as we did before, and we're going to do the same process of writing down the denary equivalents for each bit position. Starting with 1, we're going to multiply by 2, and continue on until we get to our last number, which is not going to be 128, it's instead going to be -128. This will be the only difference we have between these 2 methods, so we're going to continue on as before, circling the numbers which have a 1 and crossing the numbers out that have a 0. So the first number we're going to circle is the -128, circle the 64, cross out 32, cross out the 16, circle the 8, circle the 4, cross out the 2, and circle the 1. Let's now add up these circled numbers. We get this sum, and the answer is going to be -51. Let's write that number over here, and we're now finished with part B.